Okay, hey guys. My name is Wayne and this is Daryl. We'll be presenting on a very brief presentation on deep learning and neural networks. So like we are kind of amateurs, so please forgive us if we make any mistakes. So what is deep learning? So it is a class of machine learning that teaches computers how to learn by example. So like monkey see, monkey do, but with computers. So you can actually help you recognize whether you're happy, surprised, emotions, or you can do stuff like speech recognition. So in comparison, so deep learning revolves around the idea of a neural network. So in comparison to artificial neural networks, right, a real neural network is comprised of something called a neuron. So the dendrites will pick up signals from other neurons. Then after that, it will send the signal down. Then when it reaches a particular action potential, it will transfer information via something called neurotransmitters. And then it will get passed on. These ions will get passed on to other neurons as well. So artificial neural networks work around the same way. So you see these little squares here. They're all neurons or nodes in the network. So these are the inputs, these are the outputs that determine whether it's, for example, an apple or not an apple. So an artificial neural network comprises of fundamentally an input layer that receives the information, which is like your senses, like your 5 senses. Then after that, an arbitrary amount of hidden layers, an output layer, and a set of weights. So how this will work is that first of all, you take in the information, which is through your x. Then after that, you multiply it by the weight. Then you add a bias. The bias is like your y-intercept in a linear function. So after that, you have these intermediary hidden layers, which is like your polynomials. Like in order to refine the function, right, you have your x squared, x cubed to make it more accurate. So the number of hidden layers, it is dependent on what you're trying to look for. And having too many hidden layers can actually make your prediction model too precise, so it cannot adapt to many differing situations. But having too little hidden layers will make the thing seem like a linear function. So you can't really recognize many other cases. So the number of hidden layers will be dependent on the scenario. Then after that, you have something called a activation function, such as your sigmoid function. So this will actually transform your After calculating the weight times input plus the bias, which is your intercept, this would transform the output appropriately to the next node. So the passing of information from node to node is something called feed forward. So after that, once you come out with the information, like the final output, right, you compare it with the actual product. Then after that, after comparing, this is something called the loss. So after you obtain a loss, right, there will be a process called backpropagation, which will try to correct the weights on connecting each node to each other. So these weights will determine how probable is it, right, that this is an actual function. Yeah, so in order to explain further, we'll be watching a video.
Okay, so now I'll be moving on to more practical applications of neural networks and deep learning. So as you know, there's this company called OpenAI, which is a non-profit organization that researches AI, and is backed by someone like Elon Musk. So they have a lot of funding to conduct research on AI. So one of their projects is that they actually conduct research using Dota, which is a video game where 10 players are pit against each other in teams of 5. So it's a very complex game where there are a lot of strategies that need to be involved. So actually in 2017, there's this annual competition where all the pro teams come together to compete against each other. So it is in this event that OpenAI introduced their program, and they pitted against the professional player Dandy. So despite being a professional player of 8 years, he was quoted saying, "Please don't bully me," to the bots. So the bot was able to predict a lot of his actions and respond in a manner that he was not able to comprehend. And Elon Musk, of course, took to Twitter to posting about OpenAI and how good it is. So even other professional players stated that it took them 8 years to learn the strategies that the bots were learning intuitively through their machine learning. So what this bot was able to do was that it was able to emulate several human lifetimes of experience just through deep learning. So it's kind of like a brute force method where it keeps conducting test scenarios over and over again until it finds the scenario where it has the best fitness, or in this case, the scenario where it's able to answer to every scenario. So what this lesson learned from OpenAI was that as in the subsequent year, so this year TI8, so in this competition, the OpenAI was upgraded, so he was able to have a 5v5 against pro players. Although the pro players were still able to win the OpenAI, the AI was able to have strategies that the humans would never have came up with in the first place. So it presented an opportunity for humans to learn from AI to find ways that the AI can work outside of human limitations. So for example, as for humans, right, we need to look at several visual inputs to be able to have an output. However, the AI doesn't need to have that visual input. It can just, it has data available everywhere. So in a way, if let's say there was an equal platform, the AI would always be better than humans. So moving on, by utilizing deep learning and neural networks, we can find solutions that we may never think are possible before. So for example, there's this thing called Challenger Deep. So at the bottom of the ocean, which is called the Mariana Trench, there have only been 2 human-controlled vessels that have been able to explore the bottom of the ocean. So perhaps in the future, we can utilize this AI to be able to search for more answers at the depths of the oceans. But that being said, machine learning is not perfect, so there are still times where we will still have to use human input to be able to interpret what the machine is telling us. So with that, we come to the end of our presentation. Thank you.
So any questions for them? So can you train an AI to solve city final exam?
Maybe if they have enough test cases and we have the answer key.
If you have the answer key, then you don't need AI, right?
So to be able to predict future
I see. Alright, thank you.